Hey kids! All right, we are doing lesson 10 today, and it's kind of a big one, so prepare to take a few notes and then we'll jump in the book. There's a lot to do. The objective for today is to compare and evaluate expressions with parentheses, and the expression part means let's just set it up so we can solve it. But we have to evaluate it as well, so then we solve. Sometimes they'll say, write an expression, and that means just, without the equal sign, without the answer. But we do have to evaluate today. Evaluate is a super fancy word for solve it, get the answer. This right here is what I call PEMDAS, and so a lot of people in math will talk about this, and it's rules for the order in which problems need to be solved. So let me show you an example of what could happen if you do it wrong. This is the order. Parentheses has number one priority. Exponents come second. Multiplication and division have the power, but they have the same weight. And you would solve left to right. So when you see multiple signs in an expression, you would just solve left to right if you have both division and multiplication in a problem. So you would take the numbers on either side of the sign. I'll show you that in a second. And then the last one is addition and subtraction. Now, I always like to think these are the weaker ones, but these two have the same weight as each other. You just solve left to right again. So what happens is if you have something like this where you have multiple operations, this is an operation, this is an operation. So let's say you have 24 divided by 6 times 2, okay? And there's no parenthesis there. You have to think about the PEMDAS before you solve. Some kids will say, well, I know 6 times 2 is 12. And then if I could do 24 divided by 12, then I get 2, okay? So it's not about what's easy, and it's not about what you want to do with it. It's about following the rules of mathematics. And so 2 is the wrong answer. Wrong, okay? And if you get that, you could say, well, I did it right. This is the answer. This is 12, and then 24 divided by 12 is 2. Sure it is, but that's not going to solve the problem. And when you have things that are from word problems, this is wrong. The correct way to solve it is to solve 24 divided by 6 first. And so if you get this, then you would have your 4, and 4 times 2 is 8. The actual answer is 8. I mean, mathematically, you might try to prove it that this is right, but this, according to the order of PEMDAS, is the answer. And so it's really important to know what this is, okay? And again, this is just another example, but it has a negative, and so I don't really like to talk about that too much. There's more here. Today we're going to have some tape diagrams to show pieces that are happening or multiple times. 3/4 of 9 plus 11, because again, we have all these phrases. So here's the 9 plus 11, and we're going to take 3/4 of that. So if it was broken into 4 parts, we need 3. Look, always think if you've got multiple operations, look for where to put the parentheses. Think about what comes first. Other examples that will come, I'll go over this in a second. Word form, you have to know how to write it today. And so it's going to look something like this, 3/4 of the sum of 9 and 11. Now some kids will say 3/4 times the sum of 9 and 11. It's the same thing, and you can say either. But you need to say sum, and you need to use difference to show what it means to get the answer to an addition problem or the answer to a subtraction problem. Now, with that said, there's more. This has lesson 10 with the objective, compare and evaluate or solve expressions with parentheses. So this is what I was just talking about, 3/4 of the sum of 9 and 11. You first have to get the sum, then you can take 3/4 of that. Okay, this is what we just were working on for a couple days, fraction of a number. Okay, and you can get the number because 9 plus 11 is 20. So when you get that, you have 3/4 times 20. Solve away, and then you get 15. And another one, For B, if I have this, it's 5 times the difference between 1/3 and 1/4. So the difference has to be found first. You have to find the difference first before you can repeat that difference 5 times. But once you find that, then you have your answer. And for the last practice problem, if you have something like the product of 4 and 2 divided by 3, you can't divide by 3. You can't divide either of those by 3 until you get the product of these two numbers. Must multiply first before dividing. So that is what today is all about. Lots to it. So we're going to write expressions to match the diagrams and then evaluate. So, if you think about this, I have to get the sum, and then I see that the sum is broken into 3 parts. So you might think about what is the brand new word. What is 1/3 of the sum of 8 and 9? Okay, and that's a different one. Okay, so what is that? So what I would need to do is take my word form, which is, you guys don't have to do it today, you do it on another activity. So you have to understand the word form so that you can create it and then show it in the model and then solve it. So what is 1/3 of the sum of 8 and 9? Let's start with the sum of 8 and 9. And then I want to take 1/3 of that. Now, can I do it this way? Yes. Can you also do 1/3 of the sum of 8 and 9? Yes, you can do it this way. Guess what? There's also 1/3 of, this is a fancy thing for multiply. Okay, so a dot, you may not see that, or you may just see it on a test somewhere. 8 plus 9. Okay, so however you want to set it up, there are multiple ways to do it. And the big idea is that you need to take 1/3 of 17. So 1 times 17 over 3 equals 17/3, which is equal to 5 2/3. So you finally have your answer. Okay, so 1/3 of the sum of 8 and 9 is 5 2/3. And so that's kind of what today is all about. Let's jump right in. So if I have the sum of 3/5 and 1/2 3 times, so it's repeated, then I have 3/5 and 1/2. And I need to get that sum first before I do the multiplication. So put the parentheses around this operation before you multiply it. That's the only way that it's going to actually work. Now with adding fractions, this lesson we're applying everything we know up to this point in modules 3 and 4. So we're working with fractions. When I add fractions, I have to have common denominators. So I'm going to change to tenths before I multiply by 3. So if, again, this is my scale factor, 5 times 2 is 10, then 2 times 3 is 6. And if 5 is a scale factor, then I get 5 here. And so I have 11 tenths. I'm going to do times 3 over 1, and you can rewrite it as 11 times 3 over 10. And then 33 tenths, and 10 fits into 33 3 times with 3 left over. And we can move on. Write an expression to match and then evaluate. That's the same set of directions. I don't know why they have it twice. 1/6 the sum. Notice they don't even have of here, but that it means we're taking 1/6 of the sum of 16 and 20. Sum means add, and I have to get this first before I can take 1/6 of it. So you can still put 1/6 the sum of 16 and 20, and I can set it up like this, or you can do 16 plus 20, put it in parentheses, and then take 1/6. Either one is okay. because of the commutative property. Doesn't matter. I can move this around. Multiplication and addition, it's going to work fine because I'm going to solve this first. So add, get 36. Now I'm also going to show you what we learned a couple lessons ago, and it's that cross-canceling. So if I was to move the 6 instead of 1 6, I just shuffle it over here and have 36 sixths. That would make 6, and 1 times 6 is 6. So our final answer is this. So solve parentheses first so you can get that. Subtract 5 from 1/3 of 23. Now, I need to get 1/3 of 23 first, and then when I have that product, I will then subtract 5. Now this is one where you can't mix up the order. The only place you'll be able to subtract 5 from that number is when this is the whole. Okay, so 23/3 is what our multiplication works out to be, and then minus 5, but I don't want to use that. I need to have a mixed number here. So how many times can 3 fit into 23? 7 times, because 7 times 3 is 21. 22, 23 gives you the 2 left over. It's 7 2/3. Now I'm going to take 5 away from this, and suddenly that's a whole lot easier than it was here. So 7 minus 5 equals 2, and 2/3 take away nothing is 2/3. Okay, next one. 3 times as much. Let's straighten this out for a sec. 3 times as much as the sum of 3/4 and 2/6. 3 times as much as the sum of 3/4 and 2/6. Again, when we're adding, this is back to module 3. You can't add if you don't have a common denominator. The lowest common denominator, the best one, is 12ths. So you want to use the lowest, keep things as simple as possible. That means this is not the scale factor. How do I get from 4 to 12? Times 3. 3 times 3 is 9. How do you get from 6 to 12? Times 2. So 2 times 2 is 4. So now I have 3 times 13/12, and I can do, I could just leave it like that. And let me show you here with this commutative property when I move it around. If I use 3 as a common divisor, I can simplify this fraction right here. It doesn't have to be opposite sides, like bigger on the top and smaller on the bottom. I can use the 3 as a divisor for both of them. 3 divided by 3 is 1, 12 divided by 3 is 4. And then I end up with 13/4. And then 4 goes into 13 4 times. I'm sorry. Duh. And a 4th. Okay? So 13/4 is equal to 3 1/4. So you can simplify in any way, top to bottom, by using a number that is a common divisor. 2/5 of the product. 2/5 of the product of 5/6 and 42. Now you get a product by multiplying. Okay, and it will help you if you just put all whole numbers over 1. Okay, now when this is set up like this, just know that if I was to take this 2/5 times 5 times 42 over 6, again 42 is a multiple of 6 7 times, and so I can have 2/5 times 5 times 7 is 35, and I'll put that over 1. Now with this one, since it's multiplication, I can again use 5 to simplify. And that gives me 7 times 2 is 14. Okay, now for the last one, last one's on the bottom. 8 copies. Again, weirdness. 8 copies. That's like 8 times. I have never ever seen that anywhere except for this super fun program. 8 copies of the sum of this and this. 4/3 and 2 more. That's so weird. 8 times the sum of 4/3 and 2 more. Okay, how weird is that? So 8 times the sum of this. Now, I wouldn't usually say 4/3, so I would just do 1 1/3 plus 2. And then that makes it a little bit easier. 8 times 3 1/3. And we can change the 3 1/3 to an improper fraction and do 8 as the whole number times 3 times 3 is 9 plus 1 is 10. And that's an awful lot. And so you end up with a big division problem, but you can do that. 3 goes into 8 2 times with 2 left over, so that would make 20, and then we'd have 6, that's 18, and then you have 2/3 left over. So fun and bigger numbers. 4 times as much as 1/3 of 8. And you see the of, put in multiply. 4 times as much as 1/3 of 8. Now, we've been working on a fraction of a number, and so I've got 1/3 of 8. Got an email, not going to check it. 1 times 8 over 3. Why is my taking up so much space? 8/3. And so 4 times 8 over 3 is 32/3, and then that would be 2/3, and there we go. And I know this is really long, and we still have 2 more pages, so I hope you guys are able to keep up. Oh, okay. Now, I don't know about the print editions here, but I've had some issues with these before where the teacher's edition, even the key, doesn't have the right answers, so this might take me a minute. Okay, circle the expressions that give the same product as 4/5 times 7, and then explain how you know. The only way you're going to know is by looking at these and reasoning through them. So if I have 4/5 times 7, okay, there are all different things that can happen with 4/5 times 7. I can have 4 times 7 over 5. Okay, which would also equal 28 over 5. So if I ever get that for anything, remember that you can switch the order. 7 times 4 over 5, that's still going to give you the same product, same answer. And so you just kind of have to think about, like, how will I get this? Also, if you go ahead and solve, 5 goes into 28 5 times with 3 left over. So if you get as far as this, you're going to have some equivalent answers. So in setting up all of these problems, like, you can look at these right away, the simple ones that we already have looked at. 4 times 7 over 5. This is the same. I could move this over, and I know that's the same. Okay, so commutative property. Okay, and then this again, it's like if I have 7 over 4/5, I've just changed the order. So we know that these two are pretty simple. Okay, now this one, I know I should work left to right, but I don't want to. 4 divided by 35 is not necessarily, like, I have to solve that, so that is not going to give us the same answer because it's going to be less than 1. 4 divided by 35 things, I'm going to have a tiny, tiny answer, so that wouldn't make any sense. If I have 4 times 7 divided by 5, that looks a whole lot like this one. So I know that that one is still the same, and again, it's just changing the order, and I'm still setting it up correctly. If you want, you can do 28 divided by 5, which is 28 fifths, which I'm showing you here is going to get us to the final answer. Previously, so if I have 7 divided by 5 times 4, notice that there are no parentheses. Now, in the teacher's edition, in the key, they don't circle this one, but if you follow PEMDAS, this has to be done first. And so if you follow that first, then you would have 7 divided by 5, and you would solve that. Well, if I do 7 divided by 5, then that gives me 1 2 fifths. And if I multiply that times 4, okay, if I have 7 fifths times 4, then that is just like this one. So in the teacher's edition, the key does not circle this one, but I don't know if they intended to put parentheses here and then not choose that correctly, but this one actually gives you the same answer. You get 28 fifths, and so that should be circled. And finally this one, and it used to be super close. These two in the older books, they looked like they were all the same problem. And then this one is going to be 4 divided by 35, which again is not the correct answer. So that one's just kind of crazy. And then I just have to move on because we have so much to cover. These are kind of fun without calculating, so you have to reason and explain your thinking. So let's check this out. First of all, compare what's on the left and right. You have to weigh these, okay? An equal sign means they're the same, but the greater than or less than means one side has more weight, is heavier than, bigger than. So if I look at 3 times 2/3, and I compare it with everything that's over here, not just because there's a whole bunch extra. Look at this one, only this. If I have 4 times 2/3 and 3 times 2/3, this alone shows me that this side is going to be greater. 4 and 2/3 is greater than, THAN, 3 times 2/3. Oops, I wrote that wrong. Times, there we go. 4 and 2/3 is greater than 3 and 2/3. 3 times 2/3. That right there. This stuff doesn't even matter. Move on. Next one. Compare what we have here. I have 5 times 3/4. That's the same on both sides. So I can just, what if I take that out? Now I'm comparing what's left. And so if I have 2 fifths compared with 2 sevenths, sevenths means it's more parts, and they're going to be smaller than fifths. And if I have the same numerator number, then 2 fifths is going to be greater than 2 sevenths because these pieces are bigger. So 2 out of 5 parts is going to give you more. Think of it in terms of a donut or cookie. You'll get more cookie if you have 2 out of 5 parts than if you only get 2 out of 7 parts. Okay, so compare 2 fifths to 2 sevenths only. And then 2 fifths is greater. Because this is all about the explanation. And then for the last one. Okay, now this one's a little bit more complicated, but let's just talk in terms of rounding. If I have about 9 plus 1, and it's a little bit more than that because it's not 12/12ths, okay, that's going to be about 10. But if I have 3 plus a little bit greater than 1, so if I have 3 plus 1, then I have 3 times a little bit greater than 4. So I'm going to get about 12 compared to about 10. And again, I'm going to have 12 on the greater side. So rounding shows that 12 is greater than 10. Okay, now we have to rush over to this last page because there's a whole big section here. They really know how to overdo it. Colette bought milk for herself each month and recorded the amount in the table below. For A through C, write an expression that records the calculation described. Then solve to find the missing data in the table. So it's kind of a lot, but it's all about understanding data. And this is a real world problem, so it's very important. She bought 1/4 of July's total in June. So if you want to figure out June's total, then you take a 4th of July. 1/4 of 2 would be the expression that you need to solve. And we know that we put whole numbers over 1, multiply across. And so in June, 2/4 is what she got. You can also put 1/2, but later on it's going to be, I'll show you why we want to keep it at 4ths. Notice the other fractions. That's why. So for B, she bought 3/4 as much in September. Now that's a fancy way of saying 3/4 of. In September, as she did in January and July combined. So before I can multiply, I have to get the total of January and July. January has 3, July has 2. Now, that's January and July combined, and then we're going to take 3/4 of that. So this is how you set that up. Solve, parentheses first, okay, proceed. And this is for September. So 3 3/4. In September, this is what she got. Now in April, she bought 1/2 gallon less, so we'll have to take off the 1/2 gallon after we figure out twice as much as August. So, well, that's easy for August. So twice as much as August, first, parentheses, put it in parentheses, and then a 1/2 gallon less. The only place you can do subtraction is to take it away from what you have. Okay, you can't put 1/2 minus. That would be totally wrong.